I'm Matthias with Thoughtworks for 2 years, and I'm going to talk to you about micro-frontends. First, some kudos to Prasanna. Prasanna is with me on the account that we're currently working on and building a micro-frontend application, and he is the actual originator of those slides. So this is me. I'm not 9 years with Thoughtworks, I'm 2 years with Thoughtworks, and I'm together with Prasanna on the account. We can say it by now, it's with Daimler, where we said from the beginning, okay, we want to build our application in a micro-frontend manner. And what we learned, what we've seen, and all those things I'd like to show you in the next slides. So a general overview. I'm quickly going to give you some context on the team and the tech stack that we're using. I'm going to introduce micro-frontends to you before I'm doing a little side to the microservices, because I believe it's like the normal evolution. We had microservices in the beginning, and then we moved towards micro-frontends. Then having a little bit of an overview of things that we particularly had to take care of, things that we stumbled upon, things that we struggled with, and the learnings we had from that. And then last but not least, give you also some insights into what we believe is the right setup to actually use micro-frontends. So giving you a little bit of context. The whole account is about migrating a legacy application, which has been built like roughly 20 years ago. It's a desktop application, it's about selling cars, and we want to put it to a web application. It will be only for the German market. It's 5 teams at current. Just recently. It's even more developers by now, and we're in 2 countries. And the tech stack that we're currently working on is, in essence, it's React, Redux, CSS Modules, React Router. This is the bare necessities that we put together that we made our micro-frontend setup working. Let me share a few things about micro-frontends. Before doing so, whenever I am doing a speech of anything that has a micro in front of it, I'm always have the pleasure to say, hey, monolith is not a bad design choice. Microservices are not there to improve or build better applications. They are needed in a certain setup. And if you don't know how to build a proper monolith, don't touch microservices. Microservices just force you to get into a manner of saying, hey, I need to build strong boundaries. I need to separate things. I can do this in a monolith as well, but I sometimes just don't do it, because I want to be fast, and I think I'm being fast if I do sidetracks. We have been enforced strong module boundaries. If you don't know how to do this in the monolith, though, you might be struggling with that, and you're just building a distributed monolith. You have the possibility of independent deployment, and the emphasis, deployment. And you have the chance of doing technology diverse applications. This can be a Python application, the other can be a Clojure application. Yes, we're doing Clojure, just for the fun of it. Microservices focus on the backend. So we focused a lot on building applications that are being able to deploy frequently in the backend. But we ended up with having usually still one big front-end monolith. And this ultimately means independent deployment, yes, but this doesn't mean you have an independent release. And there's a big difference in that, because yes, every of those microservices might provide you with an API, but your product very much likely is not necessarily an API as a product. Then you're good. Microservice is your solution. But you might want to provide an UI to your users. And at that point in time, you're shipping very quickly things in the backend, but your front end is not catching up, because lots of collaboration needs to happen in the front end. The natural next step was micro-frontends, at least from my side. We had the possibility of microservices in the backend, which came with a certain promises. There was independent release, frequent release, ship value, fast, fast, fast. That's all about Agile, right? And now we are actually being able to independently release a whole value stream. Each of those streams can be one team. What is there to do micro-frontends? I'm going to talk about 4 specific topics there. The first one is the composing multiple frontends. This is the biggest challenge. This is one you need to solve to actually get all those fragments together. The sharing the data between the multiple frontends. Because yes, It might be very nicely written in a book that every of those layers is very vertical, but ultimately things are not that vertical. They tend a little bit to the right, they tend a little bit to the left, they have touching points, and in the end you're a big company and multiple endpoints are connected with each other. Creating consistent UX across multiple front ends. There's one big advantage of micro-frontends, obviously, it's this nice isolation. But isolation also comes with humans not talking with each other anymore because they think we don't need to. The technology doesn't force me anymore to talk with each other. So you literally don't talk. And a testing strategy. Since you are not only distributed on the front-end stack, but also on the back-end stack, your testing strategy needs to adapt new technologies maybe even, but also have a strong emphasis on certain patterns. Let's talk about the composition. On the left side, we have an example of 3 services that we're currently building. An order service, a search service, a configure service. We need to bring those together because while each of them is creating value to our company, business value is only created if all of them getting together. We called this layer to get all those things together, to rule them all, a business logic agnostic orchestra frame. The name doesn't mean anything, we just called it. It made sense for us, like a picture. This is frame. And then there's a canvas in the middle, and you put multiple things on it. And you can repaint, you can like scrub it off and like redo it again. But frame always stays and keeps the boundaries. You have multiple possibilities. And the 2 main ones are to compose your frontend at build time and at runtime. And from left to right, you even see the history of our project. We started with doing it at build time, and we ended up doing it at runtime. Let me show you why. Those example services, they've been built independently. They're writing their JavaScript stack. We're using then NPM, for example. You can use any other package registry. And you just deploy it via your pipeline into this registry. Frame, on the other side, is collecting all those things. So Frame explicitly knows about what services there are around. This knowledge is in Frame and is building an app in the end. And is shipping this to an app server to distribute the front end. You have very good dependency management. Yes, NPM more and more matures. Jan, give it some kicks. Now NPM caught up. Yeah, you're also independent between the teams, which is very helpful, which is what we actually want to achieve. But in the end, it feels a little bit like you're building a monolith with different teams. You have non-atomic deployments. Whenever I want to ship something as team A, and I am on the order service, and I want to get my changes to the front and out, I don't only need to change my application and let it deploy, I need to wait to Frame also to deploy. Because Frame needs to pick up my new version and release it. We ended up with runtime, which can be on the server side and on the front-end side. We decided for the front-end side. So Frame is a pure JavaScript application, which is picking up all the CSS and JS from all the various services. As mentioned, server-side and client-side possibilities. Those are just examples. JSPM is like NPM in the front end. System.js, Frin.js, single spa, just look them up. Or the server side, where things are actually been composed on the backend first and then been sent out. Server side includes, fun, right? There are technologies from the early 20s that are emerging again and make sense again. And I dare you, someone of you used frames at some point in time. And this is essentially what it is about. Just a little bit more beautiful. But it is the concept of putting frames together. Maybe that's why we called it Frame. So we have independent teams doing independent deployment. Yes, that is what we wanted to achieve. We have finally atomic deployments because I'm providing my new version via my endpoint. So if I deployed my application, the endpoint is serving the new JS and CSS. And this is to be bared in mind. Too many network calls. You have quite some network calls. You're tweaking around there with caching maybe. You have lots of possibilities to like balance this out. The second topic, sharing data between multiple front ends. The easy way. You just push it down the properties. So this is Frame. Frame only knows about the web components it has been exposed, and it composes those. It does not know what those components are, but as a developer, I put those components in place. And then I might want to have an overarching ID, like an order ID. But I wanted also maybe to share selected car, and here it already gets tricky. Selected cars might be a very complicated structure already, and you don't want to send it all around. So using properties has its limitations, so there are other ways as well. For example, using state management tools. Redux, Relay, MobX, just some examples again. So there's the vanilla way, just dispatching events all around, and I can communicate like this. And very fast, your front end becomes an EBS, an enterprise bus. You maybe also don't want to do that. So the way that we decided for, we are sharing everything via actions. I can listen as a component to another action, I get the payload, I can reduce it to whatever I like to have in my store, but every page ultimately has its own substore. Frame has the core store, every component attaches one store. You could go into the other branches of the store, but by definition we say we don't do this. Design consistency, and here comes the human factor. Because you will get design issues while building micro-frontends. The technical one is the CSS ambiguity. The human one is the UX consistency. I bet every of you has written an application where at least once the variable item is in there. Those beautiful generic words, item, panel. So the likelihood that another team is using the same class is quite good. And that there's not so nice namespacing it is also very likely. CSS Modules. This was one of the key concepts that we had to introduce to make sure that the independence that we wanted to have between the teams is technically ensured. So every of our modules, every of our CSS classes is namespaced. We have those nicely independent teams, and they don't really necessarily need to talk with each other, which is at first a good thing. Right? You bring things in the end together. And then you realize the one team, this is an actual example, does autosave. The other team clicks on a save button. The one team has an X button there, which is going to the page before. The other one has down next to the save button a back button. We had to strongly enforce a design guild. So all this Spotify concept, okay, to have all your your vertical teams, all the functions that you need to have, but you need to have also a horizontal layer. Bring those people with the same background, bring them together, and let them talk and let them agree on things. Do it as early as possible, so that an agreement on is it autosave or save here? We haven't built anything yet, so that's quite an easy agreement. But if I, as a UXer, need to go back to my team, it's like, hey, by the way, we need to change everything now to autosave. Haven't thought about this before, sorry. That can be awkward, so you fight for this. Results in not having a real agreement in the end. So have a design guild and set up a style guide that everybody can use. And make it copy and paste ready. This is the essence. You will end up that a lot of people are copy and pasting your code. So utilize that. It's like everybody is like going to Stack Overflow and is copying the code out. Create a better source for that. Create the source that you actually rely on that enables you that things are looking the same. Coming to the testing strategy. Two things we emphasized on. And this is consumer-driven contracts and functional tests. Because there was one thing that we agreed on and said, okay, the data that we're going to share is not only via our Redux store, but we let the backends communicate. So there we can apply contract. This is a technology that we're familiar with. Additionally, we said the functional test will never be across other applications. So the functional test only focuses on your application, on the value that your application is creating. And that the transition from one to the other is working needs to be ensured with the contract test. Now, when you talk about consumer-driven contracts, you only think of the backend. And here, things got a little bit tricky for us. Because we said, hey, Frame is the one that is like consuming all the services. And we put all this knowledge about the services within Frame. And Frame needs to work with so many assumptions now. This component has been exported. This reducer has been exported. When Frame is running its pipeline, it's going to grab all the components it knows of. It's just a list. It's going to grab from those URLs. It's going to pass the JS. And it's checking, did you export those things for me? It doesn't do smoke tests or any functional tests on those things. Just bare necessity. Did you export those things for me? And then additionally, we put it in an error boundary. And ultimately, the functional tests themselves. And as already mentioned, we're really focusing only on the application itself. And with the combination of the contract test in the front end, ensuring that everything is present, and the contract test in the back end, ensuring that data has been correctly handed over, we make sure that even the entire user journey will work. That is a very, very hefty discussed topic. But I'm currently with a strong opinion saying we don't need this because we lose one main thing. Who's going to own this functional test going over everything? Who's going to maintain this? And this question contradicts for me the whole idea about micro-frontends, being able to have those isolated teams. So when to choose micro-frontends? You're distributed. You don't want to isolate yourself by nature. That is very sad. But if you're in a different time zone, and we're working with teams in India, so the only overlapping time we have in the morning from 9 to 1. And this we need to utilize. And we want to make sure that in the time where we are not there, or the Indian teams are not there, that every team is still able to progress. We wanted to be able to collaborate on different frameworks in the front end. It didn't happen. Everybody's using React. We have the capability, so if a new team is starting saying, hey, I do want to do it differently, they would have had the possibility. The thing is, everybody's worried about that this is happening if you're introducing microservices, that people are out of the sun using Erlang, there is using Go, and there they're using Python, and no synergies anymore. It barely happens because people stay in their comfort zones. So the people that you hired with the certain skill set is usually automatically the implementations that have been used for your microservices. It's not easy to build micro-frontends. It comes with a lot of extra hassles. Infrastructure, microservices went only viral, in my opinion, when things like Docker has been introduced. Because in this moment, you could actually utilize the possibility of doing things in small pieces. Otherwise, building all the infrastructure around is a hell of a maintenance. And ultimately, and this is the end of the slides and the talk, everything we're doing is to sustain the pace. You will not be faster with micro-frontends. As well as with microservices, you won't be faster. But if you add teams, and new teams, and new teams, and new teams, the already existing teams, they will not get slower. And this is the good thing. You're sustaining the pace. So don't let anyone come to you and say, hey, let's do micro X because we're faster than. Nonsense. Thank you.